Hi, my name is Dmitry, and I'm a Scala developer at Wix. I've been working with Scala for about 10 years, and I've been a ZIO user and a contributor for about 4 years now. And my talk is called Mind the Gap, and it's about, so I worked with on this project called Greyhound at Wix, which is a Scala Kafka library, which there's a lot of integration with like Scala, Kafka API, which is a Java API, and also we had to expose a Scala API with plain futures and even a Java API. And also, I've developed quite a few ZIO services at Wix that are had to plug into our custom Wix framework, which works with plain futures, and had to implement some contracts. So I'm going to share some insights that I've collected over the years about like bridging the gap between ZIO and non-ZIO stuff. So, sorry, need to stay closer to the microphone. So let's see. So the agenda is I'll talk a little bit about ZIO, but I'm not going to go into, like, I'm assuming some familiarity with ZIO. So then I'm going to talk about how you call from ZIO to like Scala libraries and frameworks, and how do you make your ZIO code callable from Scala and maybe even Java, and a little bit about error handling and reporting. So let's go. So what is ZIO? This is from ZIO website, which is very good, like a lot of very good documentation there. And it's type-safe, composable, asynchronous, and concurrent programming for Scala. So basically ZIO is a data type, which is roughly equivalent to, so it has three type parameters, R, E, and A, and it's roughly equivalent to a function from R to an either of E and A, where E stands for an error, and A is your happy path result type, and R is the environment, so something that you need, like a database or whatever. And so the ZIO effects, which that's the type, we also call them effects, they don't do anything by themselves. They're like, they capture some kind of a computation, and we need a runtime to execute them. So the computation is lazy and suspended, and so this is how we execute a ZIO effect as somewhere at the end of the world. And what we get back is this exit value, which is roughly compatible, roughly equivalent to either of error or success type. And so an exit is roughly defined like this. So it's a little bit, there's more to the cause type, but basically exit is either success or failure, and the failure contains a cause, which can be a typed fail, which is this your error type, which you can decide in your error type. It could be a throwable or a string, whatever you want. And also, since we're on the JVM, there can also anything can throw. So there is also this die option, which captures any unexpected errors, and that's always a throwable. So this is like the equivalent types for something that you would have in Java or Scala versus your ZIO type. So your ZIO type could represent something that is blocking or CPU bound, and it would be just in Scala or Java world it would be just a function, and it's a function because ZIO is not executing yet. It's not running. It's not like a future that the execution has already started. So we could represent just a function to A that throws, or maybe a function to try in Scala. In Scala world. And also in the async computation that are represented by future or completable future in Java, it will still be this ZIO with the error type that is throwable. So, okay, so let's see how do we call non-ZIO code from ZIO. So if it's something that is just a CPU-bound computation, we can wrap, but we know that it can fail. For example, this sequence max, it will fail if the sequence is empty. So we can wrap it in ZIO attempt, and then our results will be either success, like 3, or a failure with this fail case, because we expected that it can fail, so there's this fail case with an unsupported operation exception. And but sometimes we know, or we think they know that it shouldn't fail. Like for example, here we do the right thing and we use last option of sorted to get the max, and then we get our ZIO type that we get is called also UIO, which is like unfailable IO. So the error type is nothing, but actually it still can fail. Anything can fail in the JVM. For example, someone could pass a null into this max method. So what will happen then is that the error will be wrapped in this die case class, and this is always a throwable. Wraps are throwable. So this is the summarizing this. So attempt will fail with the cause fail, and succeed if it does fail unexpectedly. It will be a die case, or defect is also called in documentation. And so there's a gotcha here that if you use error handling methods by default, like you do, there's catch all, catch sum, they don't catch actually the die case. So that's something to consider. So if you do want to catch the die case, you should use the cause variants with the catch all cause, the catch sum cause. And the same goes for stuff like or else or retry. And there's one thing that you could do is use resurrect, which will, in case your error case is already throwable, error type is already throwable, it will lift your die case into your resurrect your die into a regular fail. So let's see. So we saw about CPU bound, and now we'll see about blocking. So we can call any kind of blocking thing, like read line from standard input, which is blocking, and we use attempt blocking for it. And we can also use something similar for when we know it's not going to fail, or think we know it's not going to fail. We can use succeed blocking. And the difference from regular attempt and succeed is that we don't want to block the main ZIO thread pool, and there is a separate blocking thread pool that is like a cached thread pool, something similar that can grow, and the regular ZIO thread pool is fixed to something based on available CPU cores for performance. So okay, so we covered. So now this is all kinds of async. We're calling something that is async in Java or Scala world. So it will usually be returning future, for example. So then we have this nice method in ZIO that is a constructor for ZIO. It's called ZIO from future, which is just you just convert a future to a ZIO, and it even gives you an implicit execution context based on ZIO thread pools, and that you can pass to this fetch lines that may need an execution context. But one thing to to consider is that ZIO supports is interruptible, so you can cancel your computations, and but future doesn't, so there is no cancellation support. Although there is a variant called ZIO from future interrupt, which does some tricks on this execution context. In case your future returning method takes this execution context, it can interrupt between operation, like on a flat map or a map, it will fail, but it cannot interrupt some kind of a I/O operation. So we can do something similar with this Java completable future. Again, it's not interruptible, and also like both futures, the type will be throwable because that's the error type will be throwable because that's the only error type, that's the implied error type of these constructs. So, and we can do some kind of, any kind of a callback-based operation. We can use ZIO async. This is a little bit more complex, but basically, let's say we have a Kafka future, which is a custom Java future-like thing, and the Kafka future has a when complete callback. So in ZIO async, we get a callback from ZIO, which we can then call this CB thing. We can call it with either ZIO success or failure, succeed or fail, and we just have to translate this when complete A or E. We have to translate it to failure or success, and but actually Kafka future also provides a cancel method, so it's actually better than plain Scala future, and so we can do a little bit better. There is a version with that's called async interrupt, which looks even scarier, but it's basically the same thing, but you can also return in this either left of either, you can return a ZIO effect that will be called when ZIO is interrupted, and this effect we use attempt blocking because maybe it's blocking, and we use the Kafka future cancel to cancel whatever operation was running for Kafka SDK. So this is about ZIO calling Scala. Now, if we are working with, we're writing a library that we want to run in ZIO, but we want our users not to use it from regular plain Scala code or even Java, or we have to plug it into some framework that we have to extend some predefined trait or class, and or sometimes there is a callback in our Scala API, but we want to implement the callback in ZIO. So then we need to kind of convert from ZIO to non-ZIO world. And this is, we come back to our old friend unsafe run that we saw before. It blocks until ZIO operation is complete, but it produces this exit value that we saw before. So, but exit is a ZIO type, and the caller will most likely want an A or an exception. So if our effect is error type is throwable, we can use this nifty get or throw method, which will, in case the exit is a failure, it will even attach the ZIO fiber trace, like a special stack trace that ZIO maintains, to your regular exception that has been thrown somewhere in your ZIO effect or computation, and we'll see a little bit about it later. And if E is not a subtype of throwable, you can do a get or throw fiber failure, which will just wrap your whatever string or your error type in this fiber failure exception, or you can do a map from your custom error type to a throwable. Before you do a get or throw, you use the map error exit. So that's that. And let's say your client is actually prefers a try, so you can give it an exit to try, or you can make it an either, but just to note that in case of either, you basically lose the, in the left case, you will not get the fiber trace, which can be helpful, as we will see. So a gotcha about this unsafe run, if you do, let's say you have some kind of a fiber that you want to start in your unsafe run, but you want to return a value to your caller that maybe controls this fiber or unrelated to the fiber, but your fiber needs to keep running. So here I have this example where I'm creating this trait called heartbeat, which will print heartbeat every 10 seconds, but you can stop it by calling stop. So in this flow, I'm forking a fiber and just running forever, repeating forever every 10 seconds for printing heartbeat. But actually, as it's written right here, the fiber will be interrupted immediately, because at the end of unsafe run, its parent fiber dies, so the fiber will be interrupted. So the way to actually achieve what we want is to do a fork daemon, which will disconnect it from its parent, or you can do like fork scoped with scopes. Like, I'm not going to go into scopes, but they're basically ways to manage resources. Okay, so let's look now. So we saw that the regular unsafe run is blocking, but if our client doesn't want a blocking operation, we can do a run to future, which is pretty much what it says. It returns a future with if your effect has to be with error type that is throwable or subtype of throwable, and Scala futures can also be converted if you need to completable future, and you can also use it to integrate with any kind of async callback based mechanism, basically do on complete and complete some callback. So now we'll look a little bit about at error handling or reporting. So we saw that the get or throw, I mentioned it, that get or throw will give you some fiber trace information from your error, and it's packaged in a normal throwable as a suppressed exception, and you will see it in anything will log it. If you log your exception, you will see it in the log, any JVM code that does that. And here I'm giving a little bit of an example. Let's say you have this ZIO lib, which is a ZIO library, and it has some kind of steps. And there are methods, and there's one publicly exposed method called calculate, which is exposed as a non-ZIO, just so we do run ZIO throw. And then there is a Scala app that calls like one method that calls another method, and then it does the calculate. So let's see what happens so our last step blows up. So let's see how the trace looks. So first we get the runtime exception, or its regular exception stack trace. And it's actually not very useful because it's just one line in our code. Everything else is the machinery of like thread pulls and ZIO execution run loop. But then we also get this nice suppressed, we get the suppressed caused fiber trace exception, which actually has the methods in our ZIO flow. So this is actually very helpful. And this is something that is this issue with the first exception is like a common problem on async systems in Java or Scala world, at least until Loom. And ZIO kind of solves it with this fiber trace. So it's very helpful, and it's like I consider it a ZIO killer feature. But we don't, like when we saw this in this helpful trace, we don't see any code that is actually in our Scala app. We only see the ZIO part, and we see this pretty useless runtime exception start trace. So there's no trace on the Scala app and no trace. So what can we do about that? So we can actually put an implicit trace in our run ZIO throw in our calculate. So and then we will get the Scala app calculate internal, which is one line where we can get it in our fiber trace from ZIO, which is already better than nothing. And one trick that you can do is that you can instrument your, rewrite your run ZIO throw a little bit, and you can capture your stack trace before you actually execute your effect, and then you instrument your effect to append your captured stack trace if it fails. So this map error cause underscore dot trace, this basically appends your stack to any error that will be thrown out of this effect. And then what you get is this, you will get, like, I added this delimiter line, so you get this, this at the top in green you see the regular fiber trace, and then at the bottom is this stack trace up to your unsafe run or your ZIO library. This is something that could be helpful, but it's a caution is that it's capturing stack traces. It has some overhead, so you don't want to do it probably in performance, like in any type loops and like short calculations, and only like on a big I/O bound methods, computations. So in the performance sensitive operations, you probably don't want it. So I guess that's it. Thank you, and mind the gap.